Hey, here we are. I hope you haven't been outside in this terrible weather. It's just sort of coming and going. But anyway, so tonight what we're going to do is carry on with chapter nine. And the last time we met, actually, I made a recording over the weekend, if you noticed it. That's when I discovered that there's a little bit of a problem with Blackboard. I've never seen this before at Fordham, but
Like 不管什么东西, I have to say it 20 million times for them to actually listen. And then if I
the Blackboard informed me that after I'd posted two videos, that there simply wasn't enough room for any more of them. And I've never had that experience before with Blackboard or with Fordham. So what I did was I went to YouTube, where I have an account, and I created a playlist there. So if you're looking for that video, you can go to my YouTube account. And now, of course, I'm already there, so you can see I'm already in the right spot. But if for you, you're going to be looking for the name is Dr. ACA. Okay. And once you type that in, it'll take you right to my account. What you're actually looking for is a playlist. All right. So I like to organize all of my folders here. And so let me show you where that would be. So view your channel,
So
play.
sorry. So are all of the recordings for class going to be on YouTube instead of on Blackboard?
Yeah, I'm afraid so because they I mean, I'd never heard of this. Maybe it's because it's the summer, but I've done this before. I've actually done classes for Fordham. They were 100% online, which means every single lecture was recorded and it was stored in Blackboard, and I never had a problem before. And then all of a sudden, when I recorded the one over the weekend, I was getting ready to put it in Blackboard, and it just said, "Sorry, you don't have any more room." So I'm going to move the other two off of Blackboard into this account too. I just haven't had a chance. But if you look in under playlists, you'll see it right here, Econ 2142 Summer 2026. And that's where it's been hiding all this time. So what I basically did though is I did actually a lot of reviewing of what we've been doing up to this point. I didn't want to start anything completely new since it was a holiday and all, but I basically went back, revisited a lot of what we'd been doing, and that includes the calculator skills. But right now, what we're going to do is go back to chapter nine, and we're going to pick up where we left off. And that means that we're going to do some of the Excel spreadsheets that we never got a chance to do before. And also at the end of the chapter, there's a discussion about how to test hypotheses about the population proportion. So far, we've only focused our attention on the mean. And so the approach is the same. It's just that the test statistic and critical values will be different. So let me just get this stuff opened up and then we'll get started. But I just want to make sure you're all aware of it. I did send her an email, but it was a long holiday, let's face it. So if you missed my email, this is where you'll find all the videos from now on. I would, obviously I'd rather put them in Blackboard, but what can you do? I mean, I have no control over this stuff. So who knows? All right. As long as it works. I know that this works. Um, and what sometimes happens is when I put videos on my channel like this, sometimes people from outside will watch them, which surprises me to no end because they're usually something like statistics or calculus, but it happens. So not exactly ones that will have a million shares, but once in a while somebody might want to take a peek. So there it is. And so let me just get Blackboard open now. Um, get everything open. Oops, let me get that out of here. No, here we are. Okay. So yes, here we are, Blackboard, Fordham users. So I had previously had some Excel spreadsheets in here, but I'd hidden them because I wasn't sure when we were going to use them. They should be available now. Um, Specifically, within chapter 9, you'll see, besides the actual notes, I mean the slides, which are here. Let's get those open. And then the handwritten notes that I've used. Now, so far, there have been 3 recorded lectures. And so there's 3 sets of handwritten notes. And those are actually here. Those, I didn't have to move those because they don't take up a whole lot of space. Um, I don't know what's going on here. Here we go. All right, so let me download this. Okay, great. So the 3 that we should be working on here are called oh, here it is. Okay, so here's Blackboard. If you look in your folder here for chapter 9, the first one is called Golf Test. This is the one with the golf clubs. Remember, we tested the hypothesis that the mean was 295 yards. So we're going to see how that would be done in Excel instead of with a calculator. So let's download this one. So have this one is called Women Golf. Now, with annotations, what is that all about? Well, I've noticed that when they give us Excel templates, sometimes they don't label them properly. And so what I did was I entered my own labels. And so couldn't think of another title. So it's called with annotations. And then the third one is just plain Heathrow. It looks like they labeled that one correctly. So we're going to use these to come to our conclusions about these data sets. Get these downloaded, and then we will go on and discuss the hypothesis testing about proportions. All right, let me get these open. All right, give this thing a minute. It seems to be very slow tonight. But in each case, pretty much everything we need, well, if it's not there, we can go find it. Okay, so we got Heathrow. Again, we have golf test, and we have women golf with annotations. And again, that just means that I put in the labels that they neglected to give us. All right, so let's go back to the slides and see where these problems are. We've already done these by hand. So you'll recognize the numbers when you see them. Max flight, there it is, the golf test. So remember this one, we've got the golf balls. We have to make sure they're going exactly 295 yards. Anything above or below that is unacceptable. So we ran the hypothesis test. Given that we have the knowledge of the population standard deviation, we're going to use the standard normal distribution. And so here they're showing us how to do the p-value, but we can do it both ways. Yeah, so here's they're doing it with the traditional approach, hypothesis testing test statistic critical values, where we compare them to each other. And they very helpfully put the commands right here for us. So what we really want to do is understand what is going on here, especially if you've never used Excel for this kind of thing before, or who knows, maybe you've never used Excel at all. Believe me, you will need it going forward. You're not likely to do all of these types of problems with a calculator in the real world. You'll need an Excel or some other specialized package. So why don't we open up Golf, and we'll see as we go along what we're trying to accomplish here with these commands. So remember, they told us in the problem that the population standard deviation is 12 and the hypothesized value is 295. So they're going to have us calculate the rest of this information directly from the data. So this is the null and the alternative hypothesis. As you can see, it's a two-tailed test. We're given a level of significance of 0.05. And so the sample size, we can calculate it in Excel. The raw data is in column A. These are the actual observations. I do want to point out one thing, though, that I just noticed. Over here on the side, if you notice, it goes directly from row 16 to 50. That means the intermediate ones are hidden. So you're not seeing them, but they're still there. The reason for doing this is you can see the whole data set at once. So to come up with a sample size, you're going to type equals count. Now, if you notice, it always gives you in that little ribbon underneath the details about what information it needs. So value means tell it where to find the yards, and that will be cells A2. You can type a colon. It will select the entire column. And so it'll come back and tell us that, yes, there are 50 observations. Actually, let me make this just a little bigger so you can see it better. So that's one way. It's not the only way. There's always more than one way of determining the size of your sample or population, as the case may be. And so the next thing we need is the sample mean X bar. And the command for that in Excel is average. It's not mean, it's average. It's contrary to what it sounds like. So if you type equals average, then you can either select it manually over here, or you can just tell it once again that the data set is found in cells A2 through A51. And that's 297.6, which they gave us. It's right here. Now it gets interesting. Standard error. What do they mean by that? The standard error is the denominator of this test statistic. Okay, they don't use that terminology very often in here, but when they do, what they're referring to is that denominator, sigma over radical n. So we're going to take the standard deviation over the square root of the sample size, which means SQRT, and of course the sample size is here in cell D4, and that's my standard error. Now, what do we do with it? Well, what we really are interested in is the test statistic right here. And so you'll see here that what you're actually doing is taking the difference between sample mean, hypothesized mean, divided by the standard error. Remember from last time, that's approximately 1.53 is our test statistic. Now, the last time, if I remember correctly, we did look up the critical values, or actually, in this case, there are two critical values because it's a two-tailed test, right? So let's remind ourselves how that worked. They're not asking for it here, but I'd like to review how that works anyway. I almost forgot. I have to set up my notes here. Okay. So that we have something to write it in. And yes, and I did mention before, I forgot to show it to you, but in Blackboard, at least my handwritten notes still fit in Blackboard. So these will be in Blackboard, but the videos will have to be stored in, in my YouTube account. So it's funny, every so often they send me emails with advice about how to increase my viewership because they can see that I've got videos and, I've got viewers and all, but I guess they assume I'm trying to make money with it. But yeah, all right, here we go. Okay, let me just save it real fast. All right, so let's get back to this. Um, so with all this information, how did we figure out the critical values? Okay. First thing that we need to know is alpha. Okay, so they did tell us in here that we should test this at the 5% level of significance. And we already know that this is a two-tailed test. So therefore, the critical values will be plus and minus Z alpha over 2. That alpha defines the area of the rejection region. With a two-tailed test, it has to be cut in half. Because alpha is 0.05, of course, that means alpha over 2 is 0.025. So in other words, these tail areas are alpha over 2, which in this case is 0.025. And that's what we're going to need to look these up in the calculator. So now, if you go to your calculator under the menu second vars, the one you want is number 3, INV norm, which is the inverse of the normal distribution. And it's going to ask you for 3 important details. The first of which is the area. And then when it says area, keep in mind, it means the left tail area. So to look up this critical value here, left of it, which is 1 minus alpha over 2, or 975. Okay. These are going to be 0 and 1 because this is the standard normal distribution. Then if you pop in all those numbers, you'll get approximately 1.96. But of course, this is a two-tailed test, so that means the critical values are actually plus and minus 1.96. All right, so that shaded region, it represents the two halves of the rejection region. What that means is that if the test statistic is in that rejection region, we reject the null. That's why it's called that. Rejection region, whoops. We reject the null hypothesis, and that means accept the alternative. So in our case, if you remember, test statistic was only 1.53, right there, 153, which puts it not in the rejection region. Okay, so what does that tell us? So we can conclude from that that the test statistic is not in the rejection region. Therefore, we do not reject the null hypothesis. In this case, it means that there's no evidence to suggest, or there's not enough evidence that the mean flight of these golf balls is anything other than 295, which is what they want. Okay. So in other words, yeah, the mean was slightly different than 295, but it wasn't enough to suggest that the mean is actually different from 295. We could have accidentally picked the balls with the highest carrying time. So this means we do not have hard proof that the mean is different from 295, and that means we can continue to manufacture the golf balls in the same way. We don't have to make any changes. Okay, which is we breathe a sigh of relief because that could have been very, very costly. All right, now then the p-value, we can always use the p-value approach as well. They're both equivalent to each other, but sometimes it's more convenient to use one or the other. And so here they're showing you what it would look like with the graph. Now, the two-tailed test is a little unusual because the test statistic is actually 153. But we also have to consider the negative of that test statistic here. And so any values outside of that range constitute the p-value. It's that area that you're seeing there, the shaded region, where we are at a point more extreme than the test statistic. So what they are asking us to do here is to find the probabilities of those two tails and add them up. All right. Now, luckily, we only have to do one calculation because the symmetry of the distribution guarantees that these two probabilities are equal to each other. Okay. So in other words, you see down here, these have to be the same. All right. So in other words, let me draw my own version of this. So now instead of the rejection region, this is the p-value. The sum of these two tails is the p-value. So this region here is p, the probability z is greater than or equal to 153. This is the probability that it's less than or equal to negative 1.53. So what we probably should do is calculate one of them and then double it. So let's do this one. So for that one, you go to your calculator and hit second vars. Okay, so a lot of our menu items will come from second vars. Number 2, normal CDF, which is where we calculate normal probabilities. And it needs to know 4 things: the lower limit of our interval, the upper limit, the mean, and the standard deviation. Okay, so with this case, keep in mind these curves go all the way out to positive and negative infinity. So this probability that we're considering is everything from negative infinity up to negative 153. This is going to be entered into the calculator as negative second comma 99. All right, hold on. I've got to. It's being stubborn with me. Hold on. Uh, I knew something was wrong. Yeah, this computer is getting a little long in the tooth. And I mean, I love this tablet and all, but it does apparently take up a lot of space. And for an older computer, sometimes, and it's Windows too, and it's probably going to crash once in a while like that. Anyway, if you plug that into the calculator, see what we get. All right, so again, second vars. Number 2, normal CDF or normal CDF. 0.063. It's almost exactly 0.063. And that means each tail has a total area of 0.063. But that means the p-value is the sum of these two. .126. Now, what do we do with this information once we have it? So remember how this p-value rule works. If the p-value is less than or equal to alpha, our level of significance, then we reject the null, which means, of course, we must accept the alternative. Otherwise, then we do not reject the null. And of course, here alpha was 0.05. So therefore, p is greater than alpha, and we do not reject. Now, if you notice too, the test statistic critical value approach also told us not to reject the null hypothesis. And that's what we expect because the two approaches do not, will never give us different results. Okay, they will always give us the same conclusions because basically they're doing the same thing coming from a different direction. It's almost like they're the two sides of the same coin. So if you get a different result doing it both ways, then you know something's not right. Okay, but here that wasn't a problem. So we've got our results, and therefore they can rest and relax because we know that the golf balls, or at least there's no evidence that their mean is different from 295. Now, how about Excel? With all that being said, how would you calculate the p-values in Excel? See, this is the recovered one. Well, that's kind of weird. I'll turn this one off. All right, so let's go back to the spreadsheet. And you can see now here they're asking us to do it in three different ways, making three different assumptions because they don't know what we decided to do about the null and the alternative hypotheses. So they'd like you to be prepared for all three possibilities. So here are the commands that they're going to have us use. And these are related to the normal distribution. So for this one, the command is e dot s for standard dot dist. So this is the standard normal distribution, and it needs to know two things: the z-score, which means the test statistic, cumulative. Um, what they're asking is, do you mean like the less than or equal to probability, or do you mean like the density function? This one is always yes, okay, or true or one. Don't even worry about it. It's just true, okay? So if we had a left-tailed test, that would have been our p-value. For a right-tailed test, we just subtract it from this one. In other words, it's just 1 minus what we found here. And two-tail, which is just what we just found, they're going to have us do this. Now, the command they're giving us is kind of strange. What they're basically saying is that it's going to be the smaller of these two twice. So the way they choose to express this is 2 times the minimum of these two values. And, except for some rounding differences, it's the same as what we got. It's just kind of a weird way of doing it, but it worked. That's the bottom line. All right, now here's the part you maybe weren't expecting. During the course of the semester, there'll be several Excel spreadsheets that we want to work on, but I will want to collect them to make sure everyone's keeping up. And so what I'm going to have you do right now, although technically this isn't necessary because Blackboard should theoretically let me store everything there. What I'm going to ask you to do is just directly send this to my email account, my Fordham email account, because that way I know I'll get it. All right. Anything else? Who knows? I did this during the school year too. So I'm going to write it down here again. So there you go. You just completed your first Excel assignment for the course. Good job. Okay. So I'll give you a minute to do that. So what we're going to do now is revisit one of the other Excel the one of the other problems we worked on, but we're going to use it in Excel this time. And by the time we're done, you'll have a really good knowledge of how Excel is used for statistical procedures, at least, and other things too as we go along. We'll introduce to you. All right. So, for example, how about I think the next one is probably Heathrow. I seem to remember we did this one the last time we met here. Um, so let's go back to the slides and find Heathrow. This is the one where they were looking for airports that were qualified to call themselves superior service airports. And oh, here it is. So remember this problem. They told us all the details. Now, I think in the spreadsheet they have all the data and they expect us to do some of these, yeah, calculations ourselves. Oh, this time they didn't give us anything. So the hypothesized value is 7 because that's the cutoff point between being superior and not superior. And the sample size, by the way, the sample here goes all the way down to 61. So we're going to do count equals count A2. And you can just drag it down if you want, or you can just type it. If you slide it down there, you'll see that the last observation is 61. And that means the sample size is 60. Okay. And then, of course, that means that the sample mean is the average of A2 through A61. 7.25. Let me put that back up so you can see it better. Now, the sample standard deviation command is a little bit different because there's also a population version. We have to know how to tell them apart. So what we're going to do is equals stdev dot s. The dot s means it's a sample. A2 again through A61. Notice it is the sample. We're not given the population standard deviation. And let's see what they've done here. Hold on a second. So what that means is that we're using the t distribution. They do have the commands here, don't they? But, oh, this must be a different case because they've got a hypothesized value of 40. I don't know what that is. So anyway, so because we're using the t distribution, the standard error, well, the test statistic looks like this. All right, so the test statistic becomes this. The standard error would be this part. Okay, so let's do that first. Sample standard deviation divided by the square root of the sample size. Okay, the test statistic T. Now, this is a very specialized command. There's a way of looking this up. Um, well, all right. Anyway, let's do it according to what we're seeing here. X bar minus the hypothesized value divided by the standard error, approximately 1.841. Degrees of freedom, which is something unique to the T distribution. Okay, I shouldn't say that. There are other distributions that have degrees of freedom, but compared to the normal, it doesn't have degrees of freedom. It's n minus one, meaning sample size minus one, or 59. Okay, now remember the way this thing is set up. They're looking for hard evidence that the mean is greater than 7 because that means it's a superior airport. So therefore, the p-value, let me draw a little graph of this. To come up with a p-value here, right tail test under the T curve, value would be anything greater than 184. Okay, in other words, anything more extreme than the test statistic. So in order to actually calculate this, what we need is the probability that the T random variable is greater than or equal to 1.84. Now, here, they're doing it a little differently here. They're reading this off of a table. We can look this up ourselves. Just be aware that the calculator is structured to look at left tails. So we're going to look at this as 1 minus the probability that T is less than or equal to 1.84. And where do we find that? Second vars. Sorry, second vars, there it is. Number 6. TCDF. So it asks for lower and upper. And degrees of freedom. All right, so everything below 184. Oh, we have to watch it because remember, it's 1 minus this. Don't forget about that little detail. All right, so from this diagram, what we're actually calculating is the area below this because that's all we can do. But once we have it, we subtract it from 1 and we get the area that we actually want. Okay, and here also don't forget. Let's do it. Point 9646, but remember, we're subtracting one that from one. Point 0354. Okay. And what should we do with that information? Um, all right. Well, anyway, let's look at this. So we do know that the p-value is less. This is our p-value. That's less than alpha. In the problem, alpha was 0.05. And that means reject the null. In this case, it was mu less than or equal to 7. And accept the alternative that it's greater than 7. Okay. And that means that, of course, Heathrow is a superior service airport. Okay. So the question now is, how do we fill out the spreadsheet? This part we've already seen. And how do we translate that into this spreadsheet? Let's see. So for the lower tail, they're telling us to use the command t.dist. The number itself that we're looking for is the test statistic. The degrees of freedom is here. And cumulative, always put one for cumulative unless there's a good reason not to. In fact, I don't think we'll ever do that in this course. Because one gives you something that's not exactly, it's not a probability. Let's put it that way. We're looking for a probability. So make sure that this, if it says true or false, make sure it says true or one, which is the same thing. Now that's the 90, remember we saw that that's 9647. We didn't want that. We wanted the minus that. That would be the right tail test. So for this one, we can just simply put one minus, and this is the one we actually used. Then if it were a two-tail test, and they're going to, again, give us this weird minimum thing. It's 2 times the lower of those two. If it's a two-tailed test. Okay. So this one is done too, by the way. You can save it now and go ahead and fire it over here to me. I will collect it. This is the Heathrow case. Right. Wow, that was fast. Give you a minute to do that. And also, you know what? There's a trick I can show you how to show you all the commands, the formulas at once. If I hit, oh, look at that. The only problem is this approach makes it get very wide, but it's called control. And then you hit that little tilde symbol right next to the one. That opens up all the formulas. Look at that. Sometimes it's exactly what you want. Sometimes it's not, but it's good to know that it's there. All right, great. All right, now what else do we have here? The third one, which is the women golfers, I think that one might be part of the next section where we're looking at proportions. Let me just take a quick look here. There it is. All right, so we've got all the spreadsheets done that we're ready for now. This one we can do in a bit once we go through this part, where we're learning how to do hypothesis testing, not about the population mean, but the population proportion. Okay, and then we can do the women golfers case. All right, so let's go back to the slides for a minute and start to learn about the hypothesis testing about proportions. Now, we got to be careful with their notation. They do things a little bit differently, I noticed sometimes than other books. I guess every book is different. Okay. First of all, let's just remind ourselves what a proportion is. It's just a ratio. Okay. I mean, it's a very straightforward idea. Um, it's a ratio of some kind. So let's say I wanted to know the proportion of people in this class who are left-handed. So suppose that in a class of, let's say, 20, 3 are left-handed. Then the proportion of lefties is 3 out of 20, which is 15%. It's as simple as that. Okay. So notation wise, they're going to use plain P as a population proportion. And then they're going to use P with a little bar over it to represent a sample proportion. Just like X bar with the sample mean. bar itself can be calculated as the book. Most books set it up like this. They're going to introduce a new variable x, and of course, the sample size. And x is the number of sample elements. With a given characteristic. Like being left-handed. So in the case I just gave you up here, x would be 3, n would be 20. And so p bar, the sample proportion of lefties based on our class, be 3 out of 15, or same thing, but x is 3 and n is 20. Now, the process, like I said, of hypothesis testing never changes. What changes is what are we trying to test? And that tells us in turn what test statistic to use and what critical values. So yeah, you can see here, the three possible tests are start with a right tail test. No, left tail test. And of course, remember the name left refers to the alternative hypothesis. That just means that the rejection region is in the left tail. And then it also implies that the null hypothesis is that p is greater than or equal to the hypothesized value. And here's our right tail test. Meaning that if we reject the null, we'll accept the conclusion that the proportion is greater than p0. And of course, the two-tailed test looks like this. Either they're equal or they're not. All right, so I mean, it's a similar idea. Then there'll be a level of significance. Or alpha. And it can be either 0.01, 0.05, or 0.10. Then the interesting part comes, the test statistic. Now, unlike with hypothesis testing about the population mean, where it could either be based on T or Z, here, there's nothing to think about. When testing hypotheses about the population proportion, the Z, or standard normal distribution, is used. So there's only one possible test statistic that we might run into, which looks like this. It's a little bit messy, so they break it up into two parts. So this is it, but you see in the bottom we have sigma with the little p bar. That's this part here. And so this is the standard error of the sample proportion. But these are these little zeros remind us that these are the hypothesized. And of course, n is the sample size. That gets plugged in here. And then this is the normal. This is what we saw earlier. We've got the average minus the hypothesized value, and that gives us our z-score. And then, of course, that implies that the critical values are based on the alternative hypothesis, meaning that if we have a right tail test, the critical value is in the right tail. For a left-tailed test, or in the left tail, of course, because that's where the name comes from. And of course, the two-tailed test looks like this. And this is exactly what we saw in the previous sections. All right. And of course, you can use the p-value approach too. Nothing has changed there. So let's do an example. So this time now, oh, by the way, I do want to point something out here. This is something I should have mentioned sooner. No matter what test we're running in statistics, there's always some assumptions going on behind the scenes. And so here, if you want to be super technical about it, everything we're seeing here is only valid if these two conditions are true. Even if not, then it does reduce the accuracy to a certain degree, but it doesn't make it completely worthless. But it's something that really should technically be checked before you carry on, because then you might change your mind about what test to use. These conditions fail to hold, for example, you might resort to something else like the binomial distribution, let's say. But this is the assumption is going on behind the scenes when we test hypotheses about proportions. Previously with the means, we're testing the assumption was whether or not sigma was known. Okay. All right. So let's do that example. The women golfers. So here we go. 20% of the players at this golf club were women. That's our population proportion. They want to know they wanted to increase the proportion of women players. They set up some new promotion or other designed to attract women golfers. Now we want to find out if the proportion is going up. But we need hard evidence to conclude that our promotional efforts have passed. So that means this is a rate tell test. Means we're really trying to find out if the new proportion is better or greater than 0.20, because that would be a sign that the program worked. If it doesn't change or it even goes down a little, that means clearly the program did not work. Okay. So, doesn't look like they didn't even, oh, there it is. There it is. Okay. Now, what do we know? Well, the sample size of the women is 400. Which 100 were women. Oh, I see. No, I'm sorry. They took a sample of 100 golfers, 400 golfers, and 100 of them were women. All right, that's the important thing. Okay. So, previously they had 20%. Now in this sample, they have 100 out of 400, which means that the new sample proportion is 25%. Now it sounds like we should say, yes, of course, it has gone up, but this might not necessarily be enough evidence to prove that it's gone up. Okay. This could be the result of what's called sampling error, which means that maybe we accidentally picked a group of golfers that is more likely to contain women or something. Who knows? But it's a start. So alpha is 0.05. And we don't have to worry about these because look, 400 n times p is 400 times 0.2, which is 80. Oh, yeah, we're good. Yeah, we're good. All right, good. All right, what about that test statistic? What is our test statistic? So remember, we saw it a bit earlier. P minus P0, let's go get it back. I'm sorry, P bar minus P0. Oops, sorry, that's not right. That's supposed to be a subscript. So probably our best bet is to start there. So we know that the hypothesized value is 0.20. One minus that is 0.80 over 400. Okay. So let's find out what the 0.02. So therefore, the test statistic um, now remember, P bar is the sample proportion that we found 25%. 20% is the hypothesized proportion. So the standard, the test statistic is 2.5. And now we can do a couple of things. We can use the p-value approach, or we can do our test statistic critical value approach. And alpha is 0.05. We might as well try them both. Let's look up the critical value. And because it's a right-tailed test, based on the normal distribution, d alpha, or in this case, 0.05, how do we look this up? We know how to do this. INV norm. Either that. Now, I did mention that after a while, some of these numbers, you'll start to recognize them. So when you go to INV norm, it'll need to know the area that you're looking at, by which they mean the left tail this is what they mean. Right here, that's going to be 0.95. These two are always, with the standard normal, these are just 0 and 1. And if you plug those in, let's see what you get. This is approximately 1.645. Okay, so this critical value is approximately close enough, 1.645. We now compare our test statistic to this is my rejection region. And remember the test statistic was 2.5. Oh, okay. So that's way out here in the right tail. So it's pretty clear that the test statistic is in the rejection region. And therefore, we reject the null hypothesis. All right, so we can see for ourselves the test statistic is in the rejection region. Therefore, we reject the null hypothesis, accept the alternative. All right, so remember what they were. The null was that proportion is less than or equal to 0.20. And accept the alternative that the opposite is true. Now that means in this context, remember they spend a lot of money trying to encourage women to join the club. So this shows that the promotional efforts were successful. We have hard evidence that the proportion is greater than 20%, which is what it was before. If it's gone up, we have to conclude that the promotional efforts are responsible for it. Okay. I mean, unless it was just a ridiculous coincidence, which is still possible, but not likely. Now, that doesn't mean that, the money they spent, I mean, who knows how much benefit they got from this, but it does show that it went up. The promotional effort went into effect and the proportion of women went up. That's the bottom line. And then the piece value approach involves, once again, taking the test statistic and looking for areas that are more extreme. And since this is a right-tailed test, that would be over here. Of course, we have to figure out this probability. I mean, we can see where it is. We don't know what the value is, so we need to calculate the probability. But we need the calculator for that, of course. So let's go back here to second vars. So this is an actual probability. So it's number 2 normal CDF. Lower is 2.50 because it's the right tail. And then these stay at 0, 1. So you'll see it's a very, very small number. Yeah, oh my God, 0.0062. That's a pretty small number. So therefore, what conclusion do we draw from this? Well, the p-value, we remember alpha is 0.05. P-value is quite a bit lower than alpha. Therefore, our conclusion is that we reject the null. And accept the alternative that is greater. All right, now that means it's time to turn to the spreadsheet. We did have a spreadsheet for this. That was the third one that I opened up for you tonight. Let's get it open. And once again, we basically have to do everything ourselves. What's different here is that, oh, do you have a question?
Esta es toda la clase.
Okay.
Punto y silencio. ¿No?
All right, anyway, so if you notice here, this time the data is not numerical data. So counting it is going to be a little bit tricky. This requires us to understand some of Excel's more specialized functions. So I believe they have the commands that we need right here. Yeah, Excel is different when we're dealing with non-numerical data, as you'll see in a second. So the sample size, by the way, remember there's 400 observations. And so we go all the way down to 401 for that. Now, if these were numbers, you would use the count command, but they're not. So in Excel, the command for counting non-numerical data is called count A, A for alphanumeric data. A2 through A401. Okay, ooh, let me make that bigger so you can actually see it. Now, response of interest is female. Now, here's where you got to watch it, because if you're not perfect with this part, if you have blanks in there or anything wrong, you're going to have an issue. So what I recommend you do is copy this rather than type it, just to make sure you're not missing any unprintable characters or anything bizarre like that. If you manually type it yourself, you might have it spelled correctly, and yet one of the blanks is different or something ridiculous, and you'll find that you can't get what you're looking for. You'll just get zeros. So let's copy it and paste it. And then the count for response. Now, here's an interesting, we haven't seen this before. Count if, which means don't count all the observations. Count if between A2 and A401, only if it says female. Using a self-reference, I'm not attempting to type the word because, again, we can't be sure how it will react to the fact that it's like indented somewhat and there's blanks probably in there. So if you didn't do that correctly, you're going to get a 0 and you'll know there's a problem. By the way, if you want to get around all of this nonsense, what you would have to do is something like replace all the males with a 1 and the females with a 0 or something like that. It could be done. It might make things a little, yes.
Is it okay if you click the 400 code again? Because for some
Oh,
reason
sure,
mine only
absolutely.
says, yeah, because mine only says sample size as 2.
Oh, did you type the count A part?
Yes.
And you went from A2 to all the way to A401?
Oh, I did a comma instead of colon. Got it.
Okay, yeah, I figured there's a typo involved. Almost without fail, there's a typo in there somewhere when there's a problem. It's, what can you do? One day AI will figure that out for us, but not right now. Well, one day AI will do everything for us anyway, so what's the big deal? Anyway, as we speak, there's probably all these programs coming out, AI this, AI that, but right now we're still learning it ourselves. Okay. Anyway, so the sample proportion is easy. It's the ratio of these two. 25% of our sample are female golfers. The hypothesized value was the 0.2. And once again, the standard error here, mention it up here somewhere. There it is. I'm going to write this in here so you can see it. And this is our P0. So we're going to have square root, which the Excel command for square root is sqrt. What I'm going to do is put C's in here. We need 0.2 times 1 minus 0.2. Careful with this one. No, that's it. There it is. Let me show you what that is one more time in case you missed it. This one requires a lot of parentheses because of its complexity. Right? Don't you miss any of those parentheses. That's the surest way to run into trouble. Now, the test statistic is this. So we'll have the P bar. P bar is the, oh, I forgot to label it. Bar minus P0, all divided by standard error. And that's what we got, of course. And of course, the p-value will be based on that number. We'll have norm.s.dist of 2.5 and 1. Make sure it's always 1 when it says cumulative. Now, of course, this is a right tail test, so it's actually 1 minus this one, which is what we found. And then the two tail test, we'll use their bizarre way of doing it, 2 times the min of these two. I guess it works. Anyway, so anyway, look at it. We're going to reject this one. What do you know? This one's done too. So guess what that means? So this will be the last one for tonight, I think. I think we've had plenty of fun with our Excel. And also, believe it or not, this is the end of chapter 9. So go ahead, save this one and send it to me. And 9 is done. Now remember, 9 is our introduction to hypothesis testing. And I did mention at the beginning of the course that we're going to see a lot of hypothesis testing in this class. In fact, we're really never going to stop doing it. What's going to change is what we're testing it for. And it's going to get a little messier as we go along, but not ridiculously, but more than what we're seeing here. So what's going to happen in chapter 10 is we're going to turn our attention to cases where we're not testing hypotheses about, let's say, a single mean or proportion, but 2 means or 2 proportions. And we were comparing them to each other to see if they're equal or not to each other. And that does make things a bit messier. There's no getting around it. It can't be helped. But luckily, on the other hand, we still are using the normal and the t distributions. Later on, we'll need to introduce some new distributions to be used for certain cases where these two are not appropriate. Okay, these can't be used for everything. In spite of what it seems, the t and the normal distributions don't work for every case. Okay, they're meant for certain purposes, and that's it. So let me go open up 10. And let's see what that's all about. So again, you know already the procedure that will follow. What you don't know is the test statistic and the critical value for each case. Now, this one has 2 parts. That means it's going to be complicated. Either that, there's just a lot more cases, or it could be both. All right, we'll give it a minute to wake up. What's going on here? It's better. Give this thing a minute to do downloading. All right, here it is. So what we're going to do is look at hypothesis testing about the difference between two means or two proportions. Okay. Now, because there's two, that increases the number of possible cases and the potential approaches. But on the other hand, if you notice, it still matters if the population standard deviation is known or not. That's going to help us decide whether to use the normal or the t distribution. That part hasn't changed. Now, we're going to need some new notation, of course, if we're going to be dealing with two populations rather. Every variable that we use will need a subscript to tell us which one we're talking about. So you can see here, mu1 is obviously the mean of population 1, mu2 is the mean of population 2. Then we're going to need an x bar 1, x bar 2, S1 or sigma 1, sigma 2, et cetera, et cetera. In other words, we'll have to have subscripts. Oh, by the way, they're also going to have us do confidence intervals here. So mu1 is the mean of population 1, of course. Mu2 is the population 2 mean. The difference between them is mu1 minus mu2. We choose a sample from the first case of N1, the second case N2. They do not have to be equal to each other, by the way. We'll construct the two means, the sample means, x1 bar and x2 bar. And then this will be our best estimate of the difference between the two population means. Okay. Standard error. Yeah, you get the idea. It's going to get a little messier. But you know what? We can handle it. I mean, after all, we've been in class for a week, right? No, but there's going to be some complications. Let's just say that right up front. Let me just. So let me make a note here that this is chapter 10. And what we're doing here, as we just discussed, is testing hypotheses about two means and two proportions. So we'll start with two means. All right, so this is, I guess they'd like us to do the confidence interval first. There it is. So remember, we did review that in the beginning. That was one of the three things I wanted to make sure everyone remembers very clearly. The normal distribution, the t, and the confidence intervals, because we'll just keep needing them over and over again. And you might remember that when there's a single population, the confidence interval for mu, just mu, one population mean, either it was this one, Wait a minute. Sigma is known. Or if sigma is unknown. All right. Well, what about two means? Specifically, the difference between them. All right. Well, here we go. If both population standard deviations are known, then we have this case. Oh no, what happened? I did something wrong. Hold on 1 second. Okay, so this is the case we'll use for these are known. And I guess before they show us what happens when they're unknown, we're going to do an example. All right, let's do this. So we've got Homestyle Furniture sells at two stores in Buffalo. One is in the inner city, one is in the suburban shopping center. There is a difference in the types of furniture sold in each store, and the manager believes this can be attributed to the difference in customer demographics. They want to check out the mean ages of the customers in the two stores. So this is the data we have. We can copy this. Oh, wait, I know what I did wrong. We go. Okay. Yeah, sometimes when you're pasting like this, you got to know what format will work with your particular setup. So here we have, and we're going to call this N1 and N2. X bar 1, X bar 2, and sigma 1 and sigma 2. So basically all we're doing is plugging that in here. But the only other thing too is we're looking for the 95% confidence interval. And that will give us our z-score. Alpha is 0.05. Alpha over 2 is 0.025. Okay, so we can look this up in the calculator. Like we've done before. Two numbers, but we really only need one of them because we know that they're both the same number. They just have different signs. So we'll pick the one on the right. So we go to our calculator, second vars, INV norm, our old friend INV norm. area. And of course, the mean and the standard deviation. All right, so we plug it in to the calculator. And you'll get our old friend 1.96. And that's the only missing piece. The rest of it we have right here. So I'm going to split the screen so we can see everything. It's a little word trick. So here. Now, one thing you do have to watch out for, the standard deviations are being squared. Don't forget to square them. All right, so let's see what that gives us. So we have 81 over 36 plus 100 over 49. If we take the square root, it's approximately 2.07. Yes. And so therefore, our margin of error is approximately 0.72. All right, so what do we have? Point 94 72. Yes, perfect. So it really wasn't difficult. It was just messy, tedious, okay? So conceptually, it was not difficult at all. So in other words, now what it does show us, though, is that the age of the inner-store shoppers is definitely higher than in the suburban store. It's just a range somewhere between, let's say, 1 and 9 years. So the customers in the inner city store are a little bit older on average, which means they may want to change the way they advertise, or maybe the merchandise that they carry, something like that. So we'll get back to this next time. We'll do a spreadsheet with this tonight. I think we had enough Excel. Let's just carry on. And now look at this. Oh my God. Well, it looks bad because of there's so many variables floating around. Now, when we do the hypothesis testing between the two populations, remember, we're comparing the means. And so these are the three possibilities. Left-tailed, of course, is coming from the alternative hypothesis. The mean difference is less than or equal to some constant d0. The right tail is here, greater than some constant, and the difference is unequal to. This is my test statistic. Wow, and this is my standard error. Well, again, it's kind of more messy than difficult, I think. It's a lot. There's a lot going on here. So, are we ready? I'm pretty sure there's an example waiting for us on the next page. It's to say they're going to expect us to do it two ways. The traditional test statistic critical value approach, and of course the p-value approach. All right, let's see what we can do. We have standardized exam was given to the individuals who were trained at two different centers to determine the difference in educational quality between them. Okay, so mu1 is the mean for center A, mu2 is the mean for center B. Oh, this is good. They gave us all the data in a nice little table. Copy this without any problems. Remember, paste special. And then ask it for a picture. Any one of these will do. Oh, what happened there? Oh, there it is. There it is. But let me, you see, the problem is with the handwriting is that little things can cause it to get shifted around and it can get very messy. So I'm always looking out for any signs that something went wrong. Because once it gets all jumbled together, it can be very difficult to fix it. God, I did it again. Let me move it down here. Oh, there it is. Okay. It's really enormous. That's why it looks like this. All right, that's good. Whew. All right, I'll keep it down here to keep it safe. All right. So once again, we'll label the variables. What I want us to do is find out. It says now here we have to really watch the wording. Can we conclude that no difference exists between the training centers, which means it's a two-tailed test? Sometimes when they're not written maybe as clearly as they could be. Oh, sorry, what am I doing? Not D. No, D, we could use a D, but we're going to assume 0 here. in order to test whether they're equal to each other, oh, I see what I did wrong. Okay, I put the wrong place. It should be that this is what they want. Does this a little bit differently. Now, is the mean difference equal to 0 or not? That's what they're trying to find out. Now, if you notice, now some books would have done this. I don't know about you, but I kind of like this better. But we want to do what they're doing because otherwise you'll get confused when you're doing the mind taps. But just be aware that these mean the same thing. Okay, I'll make a note here. This is the alternative version. Okay, yeah, you know what that reminds me too. I wanted to see what's due. Now that we're into the semester a certain amount, you want to get into the habit of looking and seeing what's due. Now, this is an insanely fast class, which means assignments will pop up fairly quickly. And I may have to occasionally make some changes, by which I mean pushing them up a little. I don't think I've ever done this class in such a short frame of time. So, we may have to make some adjustments here and there. I'm going to try to always make sure you have plenty of time to get everything done, especially in the summer, but there's certain things that have to get done. So by the way, when you do look at this, I recommend you ignore this menu here. This is the one you want. This is the one that only shows the ones that are due because over here there's a lot of other stuff mixed in there that's not actually due. And it's optional practice problems. Here, this only shows exactly what's required. And you can see, oh my God, I see some ambitious people have already gotten started. 9-3, we're done with 9, so you can already do 9. A bunch of stuff from 10. This is all due on this coming Sunday night, which is the 12th. But this is assuming that everything is finished. I don't think we'll have any trouble finishing chapter 10 by the end of the week. So yeah, some weeks you'll have to do, unfortunately, 2 chapters. Yeah. But all right, we'll keep an eye on this, but I think you'll be okay the way it's set up now. Now, if you have actual issues, like let's say you're going away or there's this going on and that going on, I can always give you extensions. You just have to let me know what's going on. Like if all of a sudden your boss says, take a week off or something happens, which means, or you're going to work overtime every night this week or something. You can always ask for extensions if something goes wrong. Okay. Or if you get sick, things happen. All right. Anyway, so we also then, let's go check the level of significance, 0.05. Now we need a test statistic, and it's that terrifying, look at that thing. It's not that bad. Here, let me grab this one. Is it? No. All right. Now, by the way, this D0, just to make sure it's clear, is this number here. Zero, because we're just comparing the two directly to each other. The purpose of setting it up like this is to make it more general so that I could, for example, ask a question like this. Test the hypothesis that the average price of gas is 25 cents more in New York State than in New Jersey, and then that difference would be the 25 cents. as opposed to simply saying, are they equal or not? It gives that extra option of not just comparing them to each other, but comparing to see if their difference has a specific value. But in this book, the vast majority of the time, in fact, I don't remember seeing any examples where D0 was not zero. But just be aware that that's what it is. Okay, so with our test statistic, we have, all right, let's see, 82 minus 78. All right, the sigmas are, oh, I just realized I goofed. These are sigmas. Beautiful. All right, so they're both 10. That makes it easier. $30 and $40. All right, well, I guess we better give it a shot. Let's see. Now, in the MindTap problems, what they might do too is instead of just asking you for the test statistic, they might ask you for the standard error and then the test statistic. If they do, you're just calculating the denominator. Okay. It's approximately 2.4, let's say 15. About 1.66 if we round it to two places. Just saving it to be on the safe side. All right. Yep, that's what we got. The alpha is 0.05, so this is a two-tailed test. Giving it two values. Of course, that means alpha is 0.05. They're asking us to do this in a 95%. Sorry, alpha is 0.05. Oh, we just did this one a little while ago, so I'll just remind you that it's plus or minus 1.96. All right, here's our rejection region. Got 1.66. And of course, that means we do not reject the null. That the mean difference in the means is 0. Okay. So I forgot why they need to know this. Oh, these are the training centers. Okay. So that means that basically it just means that there is no evidence or there is insufficient evidence to show that one testing center is better than the other. Okay, so there's basically no difference. And of course, the p-value approach would have, since it's a two-tailed test, you have to consider the test statistic and its negative. So we technically need both of these, but because of the same number, we can rewrite this as 2 times the probability that z is less than or equal to 166. We don't have to add these two together. We can just do this once and be done with it. And of course, z less than or equal to 1.66 comes from the calculator. Of course, we need 4 things now: lower, upper. Oops, I just realized I goofed. That's not what I meant. I wanted the negative one. We don't need less than or equal to 166 is not what we need. We need the area in the left tail, and we can double it. Okay, so I almost screwed it up. Lower is therefore negative infinity, or negative second comma 99. Upper is the negative 166. These are always 0, 1 because this is the standard normal distribution. So we have 0.048 or 6, let's say, but then we have to double it. This is a two-tailed test. Point 0.09 692. And of course, that's well above alpha, which is 0.05. And therefore, we do not reject the null. Just like what we found when we use the test statistic and critical value approach, they have to give us the same answers. Okay. So that wasn't so bad, was it? It was just, yeah, the test statistic is a mess, but that's not too bad. And here, again, here's something we're going to explore in Excel. Excel has this wonderful built-in package. As a matter of fact, I'll tell you what, let me do this. We're going to need to do this anyway next time. If you look at your copy of Excel, look in the Data tab. Down here in the far right, there's going to be an add-in, which we will install in a minute, which is called Data Analysis or Analysis Tool Pack. If it's not there now, and if you have a PC, you can install it by going over here to File, way down here, the very, very bottom, Options, add-ins, go, and then click on Analysis Tool Pack. And over here, keep your eye on this side of the screen. It's going to change. Ah, look at that. There it is, the Data Analysis Tool Pack. Now, if you're using a Mac, there should be a menu called Tools, and it should be on your Tools menu, how to install your analysis or data analysis tool pack. And when you open this thing up, you're going to say, whoa, look at all this. What is all this? These are all these amazing statistical procedures that you can use. We're going to need some of them during the course. Okay, so we're going to see here. This is what they're referring to. Okay. All right. So, but again, we don't have time for that now. We can get to that tomorrow. And it'll produce this nice little printout with all the details, all the different p-values, et cetera, depending whether it's right, left, or two-tailed test. And so you're all set. Now, of course, as you can probably guess, when sigma 1 and sigma 2 are unknown, we use the S1 and S2, and the standard normal is going to be replaced with the t distribution. So it's the same thing. It's just that there's two of them instead of one. This is what we're used to seeing. There's just one problem. Well, you can see, let's look at this confidence interval. Look how straightforward it looks. It's almost identical to the earlier one we did with the normal distribution. In fact, let me get the other ones so you can see them side by side. Yeah, I mean, look, what's the difference? Because you've just got Z versus T, and the sigmas are replaced with S's. It's the same thing. But of course, as you know, with the T distribution, we have to specify the degrees of freedom. And in the last chapter, the degrees of freedom was always n minus 1. Well, that we didn't get so lucky this time. The degrees of freedom is this nightmare. Look at that thing. This is really going to test your computational powers to the max. Oh my God. And the even more bizarre part is that there's no guarantee it'll even end up being an integer. So luckily the calculus can handle that. Okay. Now this will be an example. You've got this Clearwater National Bank wants to compare the checking accounts and two of its branching banks, Cherry Grove and Beachmont. So we got 28 and 22 checking accounts selected from these branches respectively, and they're shown here. Let's see if I can persuade it to copy. A special picture. There we go. Oh, that's the wrong one. Oops. There we go. So what do we have here? Okay, so again, it's very similar to what we did earlier, except that now we're using the t-distribution. Well, actually, first I want us to do a confidence interval. Now, just to save a little time here, we're going to let them help us a little here. They have already gone ahead and calculated the degrees of freedom. You notice how they rounded it down to 47. In principle, the degrees of freedom should be an integer, but I did notice the calculators will give you results if you have a fraction. So it's not that big of a deal. So I'm going to put 47 up here to remind ourselves that we have 47 degrees of freedom. Alpha is 0.05. Alpha over 2 is 0.025. Let's remind ourselves how to calculate this one. This comes from the same menu. Except that it's number 4 INVT. That's going to be approximately oh 2.012. All right. And then the rest of it, we just plug it in. All right, I'm going to go copy the data again so we can see what I'm doing. So I lost all my labels. All right. I guess we can sneak them in up here. S1 is 150. S2 is 125. Sample size is 22. All right, so of course, what you should do is calculate the standard error and then the margin of error. So if I did this right, this is approximately 78. Yeah, okay, good. And so over here we have 115. So it's 115 plus and minus. Uh, 78, 28. $36.72 up to 93.28. Remember, that's the difference between the two, which means in turn that the means at Cherry Grove are definitely larger than at Beachmont. So in other words, the average balances at Cherry Grove are greater by anywhere from 37 to $193. And there's some more Excel. And then we still have to do the same thing with the T distribution. I mean, for the hypothesis test. And what else do we have? Uh, Data analysis tool pack. Now, now there's another case here. This is a little bit trickier. So you know what? Let's see. Where did we leave off? Right here. I think this is a good time to stop. I think we got a ton of work done tonight. And even though I somehow when I do this in person, I always have a break in the middle. I don't know what it is about online. Once I get started, I just can't stop. So I guess as far as I'm concerned, that's enough for one night. So tomorrow we'll pick it up here and we'll carry on and we'll learn more about Excel, the data analysis tool pack, and testing hypotheses about two populations. Okay. So I will post this in YouTube. The notes, the handwritten notes will go into Blackboard. And then I guess I'll just see you tomorrow. All right. So hopefully the weather will be better. So I'll see you all then.